Hello everyone, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video, I am going to talk about extraction methods, chemically active acid-based extraction. So my friends, most organic compounds are more soluble in organic solvent than in water, usually by distribution coefficient K greater than 4. You see the organic solvent, water. So however, specific classes of organic compounds can be reversibly altered chemically to become more water soluble. So this is a powerful technique and allow you to separate organic compounds from a mixture if they belong to different solubility classes. So what type of organic compound can be made water soluble? Compound belonging to the following solubility classes can be converted to their water soluble salt form. Organic acid include carboxylic acid, strong organic acid, and phenol, weak organic acid. Examples: carboxylic acid, you can see benzoic acid and butyric acid, and examples of phenol, and vanillin. Organic, another parachloroanilines and tributylamines. So how can organic acid or base be converted to water soluble form? Organic acid can be converted to their salt form when they treated with aqueous solution of inorganic base, sodium hydroxide and sodium bicarbonate. Salt are ionic and general ions are soluble in water but not soluble in water immiscible organic solvent. Remember, water is very polar solvent, the salt. Ionic species are well dissolved in it. So, carboxylic acid are converted into salt form with 5% sodium hydroxide aqueous solution. Sodium hydroxide is a strong inorganic base. You can see ionic carboxylate ion, soluble in water, not soluble in water. Carboxylic acid are a strong organic acid, so they can also be ionized with weak inorganic base, sodium bicarbonate solution, sodium bicarbonate aqueous solution. You can see soluble in water. Now let us try a simple problem. Here is the mixture of naphthalene and benzoic acid dissolved in dichloromethanes. So you want to separate these two compounds. What will you do? So you may use aqueous solution of either 5% sodium hydroxide or salt or sodium bicarbonate to extract benzoic acid as a salt form. So 5% sodium hydroxide or sodium bicarbonate solution and DCM in DCM where benzene is naphthalene is present. Now phenols are considered to be a weak organic acid. Phenol, the parent compound, is partially water soluble. 1 gram will dissolve in 15 milliliter of water, whereas the substituents phenols are not sodium bicarbonate aqueous solutions. So weak inorganic base will not deprotonate phenols to make it ionic because it is not strong enough. However, treatment with sodium hydroxide, a strong inorganic base, can change phenol to its ionic salt form. You can see. So let's try another simple problem. Here is the mixture of benzoic acid and paramethoxyphenol dissolved in dichloromethane. So you want to separate these two compounds. What will you do? You cannot use 5% sodium hydroxide to separate these two compounds. Sodium hydroxide will react with both the benzoic acid and paramethoxyphenol. Thus, both compounds will be extracted into aqueous layer. So, let's try this problem again. Here is another mixture of benzoic acid and paramethoxyphenol dissolved in dichloromethane. So, sodium hydroxide is too strong a base, thus it does not differentiate the strong and weak organic acid. Use of weak inorganic base such as sodium bicarbonate will differentiate between the compounds. A strong organic acid such as benzoic acid would be deprotonated and ionized, while weak organic acids such as phenols would not be deprotonated. So, organic bases, amines, can be converted to their salt form when treated with an aqueous solutions of inorganic acids such as hydrochloric acid. Recall that salts are ionic and generally soluble in water but not soluble in water, immiscible organic solvent. So amines are anilines and not ionic, and you can see ammonium, anilinium, ionic. So let's try a third simple problem. Here is the mixture of benzoic acid and parachloroaniline dissolved in it, dichloromethane. Parachloroaniline and benzoic acid. This is an amine, this is a carboxylic acid. You want to separate these two compounds, what you will do? You may use aqueous solutions of either 5% hydrochloric acid to extract the amines as a salt form and benzoic acid has remained in the organic layers. So you can separate 4 different classes of compounds from a mixture based on different solubility properties. The 4 classes are amine, organic base, carboxylic strong acid, phenol, weak acid, neutral. So you can see parachloroaniline, benzoic acid, phenols and naphthalenes. So extract with dilute HCl and organic layer, then extract with dilute sodium bicarbonates, then organic layer, extract with dilute sodium hydroxide, and then organic layer. So after separations of mixture of 4 components, we will have 4 solutions. Each solution contains 1 component: salt of amine, salt of carboxylic acid, salt of phenols, and neutral compound not chemically altered. So dissolve in dilute HCl, dissolve in sodium bicarbonate, dissolve in dilute sodium hydroxide. So let's see one by one how to recover each compound obtained from the separations process. So isolations of amine. An amine is a basic compound. It is protonated in the presence of excess HCl, forming a salt, and that is soluble in aqueous solution. This is how you separated amine from the original mixtures containing it. You can see an amine is soluble in acidic aqueous solution because it forms a salt and ionic form. However, if you change the pH of the solution to basic, amine can no longer stay dissolved because it is no longer ionic. This process is called basification. Basification is done by carefully adding concentrated sodium hydroxide solution to the solution containing the amine salt until it becomes basic. You can see added sodium hydroxide and you will get the amines. Now, in the basification step, you use concentrated sodium hydroxide solution to minimize the volume of the final solution. Recall that a dilute solution of HCl was used to extract the amine as it water-soluble salt. See the pictures. Basification must done carefully portions by portion with swirling each time because the acid-base neutralization reaction is exothermic. Check the pH of the solution to ensure that it is basic. 1 NaCl solution dilute 20 ml, and you can see 6N sodium hydroxide 3.5 ml, 1 NaOH dilute 20 ml. So final volume too large, so you have to maintain it. Now isolations of acid. There are 2 different groups of organic compound: carboxylic acid, a strong acid, and phenol, weak acid. In the separations procedure, acid were extracted using weak or strong base aqueous solution. You can see both acid can be returned to the original form the same manner. Organic acid are currently dissolved in basic aqueous solution because the acid form a salt and ionic form when you make the aqueous solution acidic. The organic acid no longer remains dissolved because they are no longer ionic and usually precipitate out of solution, and this process is called acidification. Acidification is done by carefully adding concentrated HCl solution until the mixtures become acidic. When the weak base sodium bicarbonate was extracted solution, extracting carbon dioxide gas will evolve during the acidifications. So recovery of organic acid requires acidification with concentrated hydrochloric acid solution. Recall that the extraction step for the separations of an organic acid, either dilute sodium bicarbonate or sodium hydroxide, was used. As concentrated HCl will now help minimize the volume of the final aqueous solution. Acidification must be done carefully portion by portion with swirling each time because the acid-base neutralization reaction is exothermic. check the pH of solution to ensure that it is acidic pH 3. So, separating funnel extractions process. Separating funnel are designed to facilitate the mixing of immiscible liquid, Teflon, a smaller funnel size, Teflon state, and ground. This is the picture of separating funnels. Now, separating funnel extraction procedure. Support the separating funnel in a ring on a ring stand. Make sure a stopcock is closed. Pour in liquids to be extracted and add extraction solvent. Add ground glass stopper, well greased. Now you can shake the separating funnel. Pick up the separating funnel with the stopper in place, the stopcock close, and rock it one side gently. Then point the stem up and slowly open the stopcock to release excess pressure. Close the stopcock. Repeat this procedure until only a small amount of pressure is released when it is vented. Now, shake the separating funnel vigorously. Now shake the funnel vigorously for a few seconds. Release the pressure. Then again shake vigorously. About 30 seconds. Total vigorous shaking is usually sufficient to allow solute to come to equilibrium between the two solvents. Vent frequently to prevent the pressure buildup, which can cause the stopcock and perhaps hazardous chemicals from blowing out. Take special care when the washing acidic solutions with bicarbonate or carbonate, since this produces a large amount of carbon dioxide gas. So, separate the layers. Let the funnels rest undisturbed until the layers are clearly separated. While waiting, remove the stopper and place a beaker or flask under the separating funnel. Carefully open the stopcock and allow the lower layer to drain into the flask. Drain just to the point that upper liquid barely reaches the stopcock. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.